An array model is a model for multiplication that we can use from elementary school through high school. Using one consistent model throughout the school years will help both teachers and students. Teachers can rely on students coming with given background knowledge, and students will feel more comfortable with the abstract concepts that approach them as they proceed to high school and Algebra 1. We're going to start our exploration of the array model with this example right here, where in elementary school a teacher might start by modeling 2 times 3, and they can easily see an array with 6 cubes within it. Next, we could move to an example such as this, where we're multiplying 5. We can see 5 unit cubes, and 14. We see a tens rod this time, and 4 units. I've broken that down into 2 pieces, the 10 and the 4. And we can see how the distributive property is at play here, because we get 5 sets of 10, which we see right here with these 50, and 5 sets of 4, which we see right here with this 20. The product of 5 and 14 is 70. When a student prepares to multiply a 2-digit number such as 23, we see a 20, 2 tens, and 3. By 12, a 10 and 2 ones. We can extend our model. This time we're distributing 20 to both the 10 and the 2. Followed by distributing the 3 to both the 10 and the 2. 20 times 10 gives us 200. We see that in this red area right here, which is represented with 2 100 squares, which would be similar to something like this in the classroom. The 20 times 2 gives us 40, which we see with these 4 tens rods to the right. 3 times 10 gives us 30, which we can see down here, where we see 3 tens rods. And finally, 3 times 2 gives us 6, the 6 little unit cubes we see in the bottom corner. When we combine all of these individual arrays, we have a total of 276 for the product of 23 and 12. Eventually, we can move to a more abstract model such as this one, where again we see the same 4 partial products, 200, 40, 30, and 6. As our students enter middle school, in 6th grade particularly, they will be multiplying problems such as this: 5 1/3 times 6 3/4. 5 1/3 can be written as 5 plus 1/3. And 6 3/4 can be written as 6 plus 3/4. So we can see in our model that 5, again, will be distributed to both 6 and 3/4. 1/3 will be multiplied to both 6 and 3/4. We'll get 4 partial products. 5 times 6 gives us 30, which is represented by the red rectangle. 5 times 3/4 give us 3 3/4, which is represented by the royal blue. 1/3 times 6 gives us 2, which is represented by the yellow rectangle. And finally, 1/3 times 3/4 will give us 1/4, the light blue in the corner. The total of these four, 36, for the product of 5 1/3 times 6 3/4. And when we move to high school or Algebra 1, we can still continue with the same model for multiplication as we approach multiplication of binomials. In this example, we see x plus 1 being multiplied with 2x plus 3. The same idea continues to work. The x will be distributed to both the 2x and the 3. The 1 will be distributed to both the 2x and the 3. Creating our four partial products once again, x times 2x, giving us 2x squared, which we see right here. X times 3, giving us 3x, which we see beside it. 1 times 2x, giving us 2x that we see down here on the bottom. And finally, 1 times 3, giving us the 3 ones we see at the end. The product of these two binomials is 2x squared plus 5x plus 3. And again, we can transfer this to a more abstract model like the one pictured below.